Bismillahirrahmanirrahim.
आवाज नहीं आ रही। मुझे कह रहा
अभी मैंने स्टार्ट नहीं किया।
अच्छा,
क्या?
मैं स्लाइड हो रही, बोल तो नहीं रहा।
नहीं, वो मैं खुद देख रहा था।
अच्छा अच्छा,
स्टार्ट कर।
सही। कोई नहीं, हाँ कर देना जब easy है।
ठीक है, बिस्मिल्लाहिर्रहमानिर्रहीम। अच्छा, ये
उसके ना हाँ, उसके कोई माइक में इशू आ रहा है, मैंने उसे व्हाट्सएप पे पूछा, कह रहा मुझे आवाज आ रही है।
ठीक है, ठीक। So we have to start replacement and retention study. In this study, what does this mean? What is replacement? For example, if we have some asset A, so for example, we have some machine which we are currently using. So obviously, this machine will be after working for some years, it will become old. It would have some wear and tear. So we need to replace this machine by some asset B. So what we have to find is when we have to replace. When. What we have to do in this chapter is exactly we have to find when we have to replace this machine A with machine B. So actually we have to find the time period. So in this chapter we are going to find that if we want to replace some machine or something with something else, so we have to find whether we have to replace it and when we have to replace it. When the cost would be minimum for us to replace the machine. So actually we're going to find that. So for example, this is written as economic service price. So what is economic service price? It refers to the retention time, the number of years, and that yields the equivalent lowest equivalent annual worth. So when the annual worth of the asset would be the minimum, then that you would call that year as economic service life. So we'll actually go through some example to find the ESL of an asset. For example, this is in this example 11.2. We are given that we have some machine or something, an asset. It is 3 years old now. That we have something A, it is 3 years old, and its marking value is now 13,000. For example, in this example, we have something we can call that as asset A. It is 3 years old, and its current market value is $13,000. So we have been provided this 5 year study period, and we have to find the ESL of this asset. So for first year, they are saying that the annual operating cost EOC would be 2,500 per year, and its market value at the end of first year would be 9,000. Similarly, for the second year, the annual operating cost would rise to 2,700, and its market value would decrease to 8,000. So the operating costs are increasing while the market values are decreasing as the time goes on. So we have to find when we should replace this defender's asset. So actually we have to find the end, the number of years, the ESL of this machine, that when we are going to replace this machine. For example, now, first we have to find it for, we have to calculate it for all years. For example, for year 0. They are saying that its current market value is 13,000. So if we replace now, we would get 13,000 rupees. So that year 0, it's directly given that if we replace now, immediately we'll get 13,000. That's fine. Then we have to find it for year 1. For year 1, it is they are saying that the market value is 9,000 and annual operating costs are 2,500. So we can draw this as like this. This is year 0, this is year 1. And for first year, its annual operating cost would be 2,500. Its market value at the end of first year would be 9,000. 9,000. And its current market value would be 13,500. So we are going to write the current market value in the year 0, because if we sell it now, it's 13,000 actually. If we sell the item now, we actually get 13,000. So if we are not selling the item, we are actually using this 13,000. So we are going to write 13,000 in the year 0. The annual operating cost 25 in the year 1, and the market value at the end of year 1 will be 9,000. This is given in the statement. So now we have to find it. We can find its annual operating cost or its present value. Anything we can find. For example, if we find its present value, its present worth, that would be minus 13,000 minus 2,500. Now we have to find what? We have to find present value. We are given the future value. The interest rate is 10%. The number of years are 1. Similarly, plus 9,000 P by F 10% and 1 year. So if we apply this formula, we'll get the present worth of this item in the year 0. This is fine like this. So we have used the annual worth method. We can also use the present worth method. That there will be no difference in answer. Only this value would be changed, and that doesn't affect anything. So if we find its present worth, because we have already been given this present worth in the year 0, that is 13,000. So if we find its present worth in the year 1, we'll get some value. So, for example, like if you assume its value, it would be like something like, we can say like 22,000. So we can get its present worth as 22,000 if we assume this value. Actually, we have to solve this, but I am assuming this value as 20,000. Similarly, for year 0, for year 2, sorry, what we can do, we have to again draw the diagram. For year 2, we are saying the annual operating cost 2,700, and the market value at the end of year 2 would be 8,000. So year 0, year 1, year 2. The first market value is 13,000 again. The annual operating costs are 2,700 for each year. And the market value at the end of year 2 would be 8,000. So again, we can find its present worth or its annual worth. It depends on us. We can also find its future worth. Or we can find any of these, the answer would be same. The answer would not change. So if we again find its present worth, or if we want to move like the example, we have found its annual worth. So if we also find its annual worth, what would be like? It would be like minus 2,700, because they are already annual worth, so we don't need to do anything to this. Again, minus 13,000 Now this is present worth. We have to find annual worth. So A over P. 10% and the years are 2 because we are going to divide this 13,000 over the whole span, over the whole 2 years. And again, plus 8,000, we find A, we are given with P 10% and 2. So this way we can find its annual worth, or if you want to find its present worth, we can use the same formula. Minus 13,000 minus 2,700 P over A 10% 2 and minus plus 8,000 P over F 10% and 2. So we can actually uh, follow any of these methods. We can find its present worth, we can find its annual worth. So the answer would not change. So it is fine that we have to do this for all 5 years. We are given this study period of 5 years, so we are going to do this method this for year 0, for year 1, for year 2, then again year 3. For year 3, it would be like 0, 1, 2, 3, 3,000 and 6,000. So 6,000 is the market value, 3,000 is the annual operating cost, and 13,000 is the first cost. So we can draw this diagram for year 3, again for year 4 and year 5. We can find the annual worth of present for each year. This will be something like this. Is this fine up till now?
Okay.
Okay, so only we need to find the present worth or annual worth for all the 5 cases, and whichever would be the minimum one, we are going to select that. For example, in these things, we know that at k is equal to 0, the annual worth is minus 13,000. At k is equal to 1, 8, 7, 8, 0, 0, 2, 7, 6, 2, 6. At k is equal to 3, the annual worth is minimum, 6,132. So the minimum cost with 6, this k at k is equal to 3. So our ESL, the economic service life, would be 3 years. Fine. That the economic service life is not actually a cost. It's actually the number of years. That at which year the cost of our asset will be minimum. So we can sell that asset in that year. So if we retain the asset for 3 years and then sell it, we would get maximum benefit for that product. Okay, so that's how we can find the ESL.
Okay.
All right. So this was the first question, that how we are going to find the ESL of any product. The second is, this is again the same for 5 years. We have to find the ESL. The second is replacement study, this one. For example, if we move toward a simple example like this. Like this. For example, if we move to this example. So now we are going to do a replacement study. So in the previous one, we found that at which year the cost of an asset would be minimum. So now in this replacement study, we will be given 2 assets, A and B. So what we are going to do, we are going to find at which year asset A value would be, the cost would be minimum, and similarly at which year we can adopt B assets so that we would occur minimum cost. So we would only have some minimum cost. So actually, we are going to find, then we are going to replace A and get B asset. So to get the minimum cost. For example, if we look at this example, they're saying that asset purchased 2 years ago. That some 2 years ago an asset was purchased and it was for 40,000. It's harder to be expected. So we can ignore this value, this line. It does not do anything. So we do not need any information that was in previous year. If they are saying at 40 years ago, 10 years ago, something like that, just ignore the value because we do not need that. We only need the current value. It can be sold now for 12,000. So, for example, if we are writing this as asset A, so they are saying that the market value of the asset is 12,000 now. So we can sell it at year zero and get 12,000. And if we keep on reading and kept for a minimum of 2 more years, that we can retain this asset for 2 more years. And its operating cost will be 20,000 each year with salvage value of 10,000 and 9,000 after two. So actually they are saying that this asset is currently of 12,000 after year one and year two. We can retain it only for 2 years, year one and year two. So just draw the diagram at year one. This will be 0, this will be 1. At year two, 0, 1, 2. This will be like 1, 2. The current value is again 12,000 in each case. So that's always same. At year one, what they're saying that the annual operating cost will be 20,000 for each year. So the annual operating cost is 20,000 for year one, and again 20,000 for each year. So always annual operating cost. It's annually 20,000, 20,000. Okay, and salvage value would be 10,000 after year one, 9,000 after year two. So salvage value is always positive, 10,000 and 9,000. So is this fine? Diagram fine? Is the diagram fine? That's how we have to draw this diagram. Similarly, yes, by reading this two lines, we can draw this diagram.
It's clear.
All right. So up till now, we have drawn this up till here. So it will be year two. So this was all about A, and we can call this as defender. This is our defender. This product we already have. Now the second product is B. We call this as challenger. That it is challenging our defender. So a suitable challenger, they are saying that would have annual worth of 24,000 each year, interest rate 10%, and over a study period of 2 years, and over a study of 2 years. So they're saying that a suitable challenger would have annual operating cost of 24,000. And interest rate of 10%, all that's fine, and over study period of 2 years. Fine. So is it all right that they are saying that the study period is 2 years? Study period is equal to 2 years. Okay. So what actually we know from this 2 years? That we know that for 2 years, what will be years like? Year zero, year one, year two. It is fine that for year zero, for year one, for year two. So we can actually say that what we can do, we can replace the defender in year zero. For example, if we are replacing the defender in year zero, what will it like? That we can get challenger for each year. Similarly, we can retain the defender for 1 year and then replace it by challenger. So that will be like this. And similarly, we can retain the defender for maximum of 2 years and then replace it by defender. So this is how we can we have to draw the combination. That the first combination would be that immediately replace the defender. We can immediately replace the defender with this challenger. So in that case, we have to calculate the cost of challenger for all 3 years. So that would be like challenger, challenger, challenger. Second case would be if we retain the defender for 1 year and then replace it with challenger. So we have to calculate the cost. The second case also. And third case is we can retain the defender for 2 years and replace it with challenger in third year. So that would be third our option. Now the fourth option is if we retain this defender for all 3 years. Why we are not taking this option? That we are taking this defender for all 3 years. We are not taking this option because they are saying that the defender can be kept for maximum of 2 more years. That we cannot keep our defender for more than 2 years. So this option they are negating it in the question that we cannot keep our defender for more than 2 years. So we cannot keep it for 3 years. That is why our three options are we can immediately replace a defender, we can replace a defender after 1 year, we can replace a defender after 2 years. So the options clear that how we are going to uh, make the option from the given data. So if they are clear, so for example, if we are going for option one, the first option that is cylinder, cylinder, and cylinder. So in that case, we know that it's like this. 0, 1, 2, 3. And at first year we have this our annual operating cost would be at year one. So in option one, cylinder. So what could be our annual operating cost? If we look at this question, we are saying that
Annual operation cost.
yes, the annual operating cost would be 24,000 for each year for cylinder. So our annual operating cost would be 24,000. Again 24,000, and again 24,000. So annual operating costs are 24,000 for each year. If we uh, use the defender option, actually it was like this. We are going for 2 year study period. So at 2 years, this was like this. That we have the annual operating cost of 24,000 each year. So what we have to do, we have to simply find its average. So its average would be again 24,000 because all are 24,000. So the average is again 24,000. So the option one are the cost of option one would be 24,000. We find that we are simply taking the average of these three options. In option two, what was option two? We can retain the defender for 1 year and then replace it with cylinder. So if we are retaining a defender for 1 year, so if we draw the defender diagram, so the defender current market value was 12,000, I think. Yes, 12,000. And after 1 year, annual operating cost is 20,000 and sales value is 10,000. So actually we have drawn this here. This first diagram. This one. So what you can do, you can simply find its annual operating cost here. Annual operating cost of 1 year would be minus 20,000 because it's annual operating cost minus 12,000. This is we need to find A. We are given with C. The interest rate is 10% and the number of years are 1. Similarly, plus 10,000. We are given with we need to find A. We are given with F. The interest rate is 10% and the number of years are 1. So we can simply use this formula and get the annual worth of this first value. It's fine. So they have found this as 23,200. So they have found this as 23,200. And in the second year, 0, 1, 2. So we have this cylinder. So this is again 24,000 and 24,000. So it is fine that we are replacing it after first year. So we'll get this 20,200 value from this diagram. If we solve this diagram that they have provided in the question, the 12,000 is the first market value, 20,000 is the operating cost, and 10,000 is the salvage value after 1 year. So if you find its annual worth, it will be 23,200. Simply solve this formula. So we place this formula in the year 0, and 1 and 2 would be 24,000. So now its average would be, you can find its average. So its average would be like 23,708. 23,708. So this is its average. Similarly, for option C, the option was defender, and challenger. So again, now we are going to use the second diagram, this one. So we can find the annual operating cost for 2 years. That would be minus 20,000 minus 12,000. This is, we need to find A, this is C, 10%, and here are 2, and plus 9,000. We need to find A, this is given F, 10%, and 2. If we use this formula, we can get the annual worth for 2 years, and that is 22,629. 22,629. So 22,629, again 22,629, because this is this annual operating cost, and the cost of challenger was again 24,000. So if we again take its average, we can get the value as 23,042. So we have now these three averages: 23,042, 23,708, and 24,000. We are going to select the minimum value. The minimum value was this. So the most optimum choice would be to retain the defender for 2 years and then replace it with challenger. So this is the option that keeps defender for 2 years and then replace it. So that is how we have to do a replacement study. Any issue in this?
Rather, when you take the average of the three values which we obtain actually, okay, in the three options, in the third options, you take the average of the annual worth which we get it by first year and second year and third year, yeah.
Yes.
Then you take the average, but the answer is not same actually.
What's the answer?
The answer is 23,700.
23,001. Which one? Second one or first one?
The last one.
Last one. 1 minute. 22,629 to 2 plus 24,000 divided. It's 20,086.
22.
Almost same. Almost same.
Okay.
Okay. Divided by 3, not 2, because there are 3 values.
Yeah.
20,000 plus 24,000 into 2.
Okay.
So 23,733 was the second one. So that's almost fine.
Okay.
So this is how we can get this value. So any issue apart from that one?
No.
All right. So this was all about this replacement. This last question we can actually see this is a continuation of the previous one. So all the things are same, and they are just saying that we have to find the RV of the defender that will render its equal annual worth equivalent to the challenger. So actually, we are going to find the value, the current market value of the defender that would be equal, that would equate it to the challenger. For example, in this question, we were given the current market value was this 12,000. So now in the next question, he is asking what would be the current value or market value of the defender that would make its value equal to the challenger. That it will render its annual worth equal to that of the challenger. So now we are going to find the uh, market value of the defender actually. So if we look at this question again, so first line we can ignore because we do not need to know the previous part set of the question. So we are saying that it can be sold now for 12,000 and this is the current market value. But again, we are going to neglect this because we are actually going to find the current RV. So we need to find the current market value of this uh, defender. So ignore this 12,000. So we are saying that annual operating cost will be 20,000 per each year. The same thing. Salary will be 10,000 for 1 year and at the end of year 2. So salary value is 10 year after year 2. Suitable challenger would have initial cost of 65,000, annual cost of 15,000, salary value of 18,000 after 5-year life. So the life of the challenger is 5 years, the life of the defender is 2 years. So actually if I write this something like this, make a comparison. This is defender, this is challenger. So defender and challenger. So in this defender challenger, so they're saying that annual operating cost is 20,000. So AOC is equal to 20,000 and market value or salvage value, FCA is 10,000 after year 2. The number of year N is equal to 2. So we can retain the defender for 2 years only. Similarly for AOC for a challenger, the pseudo challenger will have initial cost. Okay, AOC is 15,000, salvage 18 and 5 years. 15,000, salvage value is 18,000, 18,000. And N is equal to 5 years. So the current value, the initial cost would be, initial cost is that 65,000 for challenger and initial cost is 12,000 for defender. But we are going to ignore this 12,000 because we need to, they are saying that we need to find the annual cost. Oh, sorry, initial cost of that defender. This is we actually we have to find. Why? Because they are saying this, you read this line. Determine the RV of the defender that would render its annual worth equal to that of challenger. That we have to find its current marks value that would make it AW equal to that of the challenger. Let us say 10%. So actually we are going to equate the annual worth of defender to the annual worth of challenger. So in defender, if we draw the diagram, so that is year 0, sorry, year 0, year 1, year 2. At the year 0, at this is at year this is something P. P do not know this value. We are going to find this value. The market value after year 2 is 10,000. So this is the diagram for defenders. For challenger, the years are 5. 1, 2, 3, 4, 5. So the annual operating cost is 15,000, I think. The salvage value is 18,000. And the current market value is 65. 65. So is it fine that we are going to draw this diagram like this? That the annual operating costs are given, salvage values are given, the initial values of challenger is given 5,000, but we have to find the initial value of the defender. Simply equate this annual value of defender would be P into, we need to find A, we are given with P, the number of years, the interest is 10%, the number of years are 2. This is in negative because it was a cost, not revenue. Again, minus 20,000 directly because it is again annual cost, and 10,000 rupees plus because it is salary value. This is, we need to find A, this is F, 10% the interest rate, and the years are 2. This equation is for the defender. We have to equate this equation with the cylinder. So for a cylinder, we have this current value as minus 65,000. This is P, we need to find A, 10% and 5. Again, the annual operating costs are minus 15,000. Just simply write this, and the salary value is 18,000. This we need to find A, this is F, 10% and 5. So simply we can use this equation to find the value of P. To find the value of P. So we can use equation to find the value of P is equal to something. So it is fine. That's how we are going to use this equation. That we can simply draw these equations from this diagram. So after getting this value of P is for 24,228. So the current market value of the defender. So this 24,000 is saying that the market value of defender, if it is greater than, if we look at this line, what we are saying, that if the market value of defender is greater than 24,000, then select cylinder, otherwise that is fine. So if the current market value of the defender is something like 3,000, then we are going for replacement because we are getting profit now. So we can go for replacement then. But if the current market value of defender is 12,000, like given in this question, 12,000, we are not going to replace the defender because we will be getting loss in that case. So this 24,000 is actually the dividing line between if you want to replace the defender or not. Simply remember that if the current value of the defender is less than the what we have found from this equation, do not replace it. If the current market value is greater than the calculated value, then replace it. So was that understandable? That if market value is less than this calculated one, and market value is greater than calculated one. So in the first case, do not replace. The second case, replace defender. It is fine that in the first case we are not getting sufficient profit from that, so we are not going to replace the defender. In the second case, we are getting more profit, so we are going to replace the defender.
Clear.
All right. So this was all about this chapter number 11. So in chapter number 11, what we have to find, this is economic service life. We have done this study period, and we have considered all combination defender challenges, and the replacement value always we have found as replacement value. So any issue in this one?
No.
All right. So do you want to do this step number 9, or is this all fine?
Yes, brother, please.
Sorry.
Yeah, we need that. If you're able to explain, we will thank for it.
Okay. A moment.